So now today we are going to discuss about p block elements. So here in second year we have 15th group. 15th group, otherwise 5th A. Next 16th group, otherwise 6th A. 17th group, otherwise 7th A. Next 18th group, otherwise 8th A. Say 15th group elements: nitrogen, phosphorus, arsenic, antimony, bismuth. Next moscovium. Next oxygen, sulfur, selenium, tellurium, polonium. Next livermorium. Next 17th group. 17th group fluorine, chlorine, bromine, iodine, astatine. So tennyson. Next 18th group: helium, neon, argon, krypton, xenon, radon, oganesson. Next, see the atomic numbers. So nitrogen 7, it is added with 8, so you are getting 15. Next, you add 18, so 20, 33. Next, you add 18, so 51. Next 32, so 83. Next 32, 115. Next here also 8, you add 8, 16. Again you add 18, so 34. You add 18, 52. Next 32, 84. Next 32, 116. Next fluorine 9, you add 8, 17. You add 18, 35. Add 18, 53. Add 32, 85. Add 32, 117. Next helium 2, you add 8, so 10. Again 8, so 18. Next 18, 36. Next 18, 54. Next 32, 86. Next 32, that is 118. See, except 18th, 15, 16, 17, you add 1 8, 2 18s, 2 32. But 18th only 2 8s, 2 18s, 1 232. You add means direct atomic numbers you will get. Next, 15th group you called as nitrogen family. So it is nitrogen family and special name is nicogens. The special name is nicogens. So here, so P and T are silent. Next 16th group you called as oxygen family. So oxygen family, the special name is chalcogens. Next, this is fluorine family. So these are halogens. Special name is halogens. Next, 18th group. So 18th group you called as a zero group. So zero group elements, noble gases. Next, inert gases. Next, monoatomic gases. Otherwise, rare gases. So that special names for 18th. Next, here, general electronic configuration. So general electronic configuration, you can write NS2, NP3. Here, general electronic configuration, NS2, NP4. Here, NS2, NP5. Next here, so helium. So helium is 1s2, except helium, remaining is NS2, NP6. So outermost contains 8 electrons. This is only you called as a octet configuration, and these are more stable. Next, you see oxidation states. So in all groups, oxidation states, if you take nitrogen, so nitrogen is showing -3, -2, -1, so 0, +1, +2, +3, +4, +5 also. Next, in azide, azide means N3 -1. So each nitrogen, so oxidation state, that is -1/3. So fractional oxidation state also available for nitrogen. This is next, phosphorus. Phosphorus you are taken means -3, +3, +5. This is ground state. This is excited state. See, nitrogen is there means you can write one lone pair, 3 single electrons, compulsory lone pair, because of there is no excited state. Suppose you take phosphorus. Phosphorus you can write 5 single electrons, so many empty boxes. So you can write. Next, you come to 16th. Here, so oxygen. So here oxygen is showing -2, -1, 0, +1, +2 also. With fluorine only, oxygen showing a positive oxidation state. Next, peroxide. So peroxide is O2 -2, so -1. Next, superoxide. Superoxide means O2 -1. Single oxygen is -1/2. So here nitrogen is showing fraction, oxygen also showing fractional oxidation state. Next, you go to sulfur. So -2, +2, +4, +6. So these are ground state. So first excited state +4, second excited state +6. So how to write that oxygen? So oxygen you must write 2 lone pairs and 2 single electrons. So because of oxygen is not showing excited state. Suppose sulfur you want to write means 6 out of 6 single electrons and empty boxes you can write. So writing of sulfur. Next, 17th group. Suppose fluorine. So fluorine is always -1 oxidation state only. Fluorine you want to write means compulsory 3 lone pairs, 1 single electron. But chlorine 1, 2, 3, 4, 5, 6, 7 and empty boxes you can write. Because of fluorine is not showing excited state, but chlorine it can show the excited state. That is. Next, in 18th group, xenon only forming compounds. So that's why you can write xenon. So plus 2, plus 4, plus 6, plus 8. So this is first excited state. Fourth means second excited state. So plus 6 means third excited state, fourth excited state. So xenon also forming compounds only. One is fluorine, another one is oxygen. See, atomic radius. See, top to bottom. So top to bottom, atomic radius increases, volume, size, all are increases. So here also, atomic radius, top to bottom increases, volume also increases, size also increases. So here also same, atomic radius, volume, size, all are increases. So here also same to same. Next, density. So top to bottom in the group density is increases. So 16th group also, 17th group also, density is gradually increases. Next, so ionization potential, electron affinity, electronegativity. So top to bottom decreases. So here also ionization potential, electron affinity, electronegativity, top to bottom decreases. So here also IP, electron affinity, electronegativity, top to bottom decreases. So here IP value top to bottom decreases. So left to right highest IP value. So electron affinity is 0. Electronegativity is also 0. So that's why many properties of 18th group is going to 0. So that's why these are called as 0 group elements also. Next, metal and non-metal characters, if you see, means nitrogen, phosphorus, arsenic, antimony, bismuth. See, nitrogen, phosphorus are non-metals. These are metalloids. Bismuth is the metal. Next, coming to sixth group, oxygen, sulfur, selenium, tellurium, polonium. These are non-metals. Polonium is showing metallic character. So some tellurium also. So selenium is metal plus non-metal. Non-metal plus metal you called as metalloid. Next, here all are non-metals only. Fluorine, chlorine, bromine, iodine. All are non-metals. So that are what non-inert gases. So simply complete non-metals only but inert gases. That. Next, if you see the physical state, so if we see the physical state means nitrogen is available as a gas. So phosphorus is available as a waxy solid. So smooth solid. So arsenic, antimony, bismuth. So these are available as solids. So suppose if you go to 16th group, so oxygen is a gas. Oxygen, sulfur, selenium, tellurium, polonium. So actually moscovium, these are radioactive, livermorium. So oxygen only gas. Next these are solids only. Next fluorine, chlorine. These are gases. Next bromine. So it is a volatile liquid or fuming liquid. Next iodine. So it is a volatile solid. So you must remember sublimated compound. So iodine is a sublimated compound. Here all are gases. So that to be what? Monoatomic gases. So monoatomic gases. Next, we see the property of atomicity. See nitrogen. Nitrogen is available as a diatomic. So bond order if you see means N triple bond N. It's a lone pair. Next, phosphorus. So phosphorus is available tetraatomic. So tetraatomicity. So 4 phosphorus are available in tetrahedral form. So that is a tetrahedral form. Bond angle is 60 degrees. So generally tetrahedral structure means it will be stabilized at 109 degrees 28 minutes. But actually bond angle is 60 degrees. Because of bond angle strain, it is unstable. So unstable means reactivity is high because of bond angle strain. Next, in 16th group you come. Here oxygen is diatomic. So bond order. So that is 2 only. In between 2 oxygens, 2 bonds are there. See, actually this is a diamagnetic. So this is a paramagnetic. For the explanation of this only, molecular orbital theory is created. Okay, that is next sulfur. If you see sulfur, that is octaatomic. So that is showing octatomicity. So this is looking like so crown shape. So the structure is crown shape. S8 we are heated. You will get S6. If you heated S4, again heated, you are getting S2. S2 is similar to O2 type of structure. Next, here all 17th group, these are what diatomic only. F2, Cl2, Br2, I2. So all are diatomic. Next, these are what monoatomic gases. So here, actually in your thermodynamics, the atomicity is explained by, so atomicity in the thermodynamics, that is explained by gamma value, that is Cp by Cv value. So your physical chemistry thermodynamics. So monoatomic gas gamma equal to 1.66. So diatomic gases gamma value 1.4. So oxygen gamma value 1.4. Nitrogen gamma value 1.4. Next, here electron affinity. So highest electron affinity, see that is phosphorus. Top to bottom electron affinity decreases. So the important one, that is the phosphorus. In the group, second element has highest electron affinity. So here also 16th group, highest electron affinity. It is not oxygen, that is the sulfur. Next, highest electron affinity in the 17th group, that is chlorine, not the fluorine. So the chlorine importance, entire the total periodic table, highest electron affinity is chlorine. So here electron affinity is 0. So next, you see the catenation. So catenation is started from 14th group. Carbon is showing highest catenation. So one element continuously combining with that element only. So here nitrogen is greater than phosphorus. Suppose you come to 16th group. So sulfur has more catenation than oxygen. Next here, no need to discuss about catenation phenomena. Next. So some special properties, if you see, means allotropy. You can see allotropy. So allotropy means different physical forms. So the element is showing different physical forms. So that is called as allotropy. So here in this nitrogen is showing, bismuth is not showing the allotropy. So nitrogen, it can show in the solid state. CCP structure also it will show, and HCP structure also. It is showing two structures in the solid form. Bismuth is not showing. Next, phosphorus you are taking means that is white phosphorus, red phosphorus. These two are famous. So scarlet, some other also it will show. So remaining also they are showing. Next, allotropy here. Oxygen and ozone, that will sulfur S8. So it is rhombic sulfur. Rhombic monoclinic. These two are famous. Other than this, plastic sulfur. So black sulfur, like that, so many are there. Next, here allotropy. No need to discuss about that one. Next, we see the covalency. So means the maximum formation of bond capacity. Bond formation capacity is called as covalency. Suppose you take nitrogen. Nitrogen means so it can form three bonds. So three bonds are possible. So maximum means this lone pair also donated to another one. So maximum nitrogen can show 4. Next, you take phosphorus. So phosphorus, 1, 2, 3, 4, 5 electrons are there. Next, empty boxes are there. So 5 bonds it can form. So because of excited state is present, so 5. So empty orbitals are there. If anybody donated, it can readily take. So greater than 5 also maximum is possible. Next, you come to oxygen. Oxygen contains two lone pairs, two single electrons. It can readily form two bonds. If this lone pair is donated to other, so maximum 3 also you can get. Sulfur means excited state is there. So that's why all electrons you can write single. Next, so here it is easily forming 6 bonds, also forming more than 6 also it can form. Maximum is more than 6 also possible because of empty orbital. Why it is happening means the sulfur can show excited state. Suppose you take fluorine. So fluorine is forming only one bond. If another bond lone pair is donated, again it is coming back very fast. So that's why covalency you can take 1. But chlorine has excited state is there, 4, 5, 6, 7, and empty boxes you can write. So it can easily forming 7 bonds. 7 bonds. Next, because of empty orbitals it can show more than 7 also. Why it is showing means excited state. So xenon also showing excited state. So that's why you can write 8 electrons. 6, 7, 8, 1 more. So it can easily form 8 bonds. So one empty box is there greater than 8. So that 9 also it can form because of one empty orbital. Next concept, you can see multiple bonding nature. Multiple bonding nature. See, nitrogen small size, another nitrogen small size, these are very close. You can get a triple bond is also forming multiple bonds. So n double bond n also possible. Next, that is nh and nh. Suppose you take phosphorus is large size, another phosphorus is large size. In between these three, In these two, triple bond is not forming because of large size. Orbitals are far away. Far away means there is no side on overlapping, so pi bond is not possible. Suppose one is large size, p double bond, it can form one O, one double bond O also possible. Next, suppose this size is very large, so p two double bond O's, it is not possible. Next, you come to oxygen. So in between oxygen, double bond and double bond is happened. Suppose sulfur is large size. Sulfur is large size. So that formation of double bond character is very less. So only two compounds are there. So that is the only the thing. Next, but sulfur, it can form. One is large size, one double bond O. Compared to phosphorus, left to right we are moving, size is decreases. Compared to phosphorus, sulfur size is decreases. So that's why sulfur double bond O, it can forms. But phosphorus two double bond O's is not existed. So here no problem. So that is what fluorine and fluorine, one bond only you are getting. Next, you suppose you take in chlorine. Chlorine large size. So with another chlorine not forming, single bond only. But double bond O can exist. Next, you are moving phosphorus to sulfur size is small. Sulfur to chlorine is also very small. So that's why chlorine is readily forming three double bond O's also existed. Next, you come to xenon. So xenon is also forming only two elements. One is fluorine, another one is oxygen. So oxygen means compulsory, it can form. So compared to this one, so it is existed with four also. Xenon is forming double bond O's, multiple bond O with four atoms of oxygen also. Next, if you see the colors, so color properties, this 15th group is not showing, 16th also not showing, this also leave, but here 17th group only very important. The fluorine is showing light yellow. Next, chlorine, so yellowish, greenish yellow. Next, bromine, reddish brown. Next, iodine is showing a deep violet. Next, always you see the iodine. So this is what a sublimated compound. See, this is only special color properties. 17th group only showing majority. Other compounds are not showing. So these are the physical properties of all the four groups of p block elements.